Example 2. Saturated water vapor at 200 degrees Celsius is isobarically condensed to a saturated liquid in a piston cylinder device. Do you remember what is isobarically means? Okay. So this is important. You need to identify the condition of your problem. We start with saturated water vapor at temperature of 200 degrees Celsius. So this is initial condition. Okay. Condense, isobarically condense. This is a process to a saturated liquid. Okay. Initially it is saturated water vapor. Finally, it's a saturated liquid in a piston cylinder device. Okay. So if it's in piston cylinder device, okay, you have to consider this. The volume might be changed. Okay, or not. Okay. So calculate the heat transfer and the work done during this process in kilojoule per kilogram. So how to solve this? Okay. So you need to identify initial condition, final condition, and isobarically process. Okay. And identify what is the requirement of the question. You need to find the heat transfer and the work done. Okay. So back to the general energy balance. E in minus E out. Delta E. Okay. Okay. If you still confused, how do they get into here? Okay. So get back to the original equation. Q minus work, or you can just Q. You state the previous equation. Q in minus Q out. Minus Q in minus Q out plus work in minus Q out. If you still confused about it, okay. So get back to the real equation. So this one is already has been identified, has been recognized, and what's left is only work in. You don't have work out, right? And you don't have Q in. You only have Q out in this case. Okay. How do you know you don't have Q in? Okay, because from saturated water vapor into saturated liquid. Okay, what is happening? Do you losing heat or do you absorb heat? Okay, that is a question mark for you. Okay, so what's left is work in minus Q out equals to delta U, because delta KE and PE is equal to 0, and delta U is actually MU2 minus U1. Okay, and Q out. So rearrange, you have this Q out equals to work in minus MU2 minus U1. Okay. Okay, water from 200 degrees Celsius to saturated vapor, you are losing heat because you want to change from saturated vapor to saturated liquid. Condensation, right? Okay, and condensation. So this is a time when you need to use your properties table. Okay, we start with table A4. Why are we using table A4? Okay, because you are given temperature. This is temperature table. Okay, so at T1 equals to 200 degrees Celsius, S1 equals to 1. Why? S1 equals to 1 because it is saturated vapor. Okay, remember this one? Okay, if you forget, please go to the previous notes about this. S1 equals to 1. So at this condition, you need to identify the properties. V1 is actually a specific volume. Specific volume 1 is actually specific volume Vg, because you don't have Vf. So it is just straight to the point. V1 is actually Vg straight away because it is saturated vapor. So this is the value. U1 is also Ug. So this is the value. Okay. Since isobarically means pressure is constant, therefore P1 equals to P2. Okay. The state, the change, we are having changes of phase, okay, but the pressure is constant. Okay, so this we have solved for the state number 1. So next we go to state number 2. Okay, the temperature is constant. T2 equals to 200 degrees Celsius. Okay, but X2 equal to 0 because we have saturated liquid. Change into saturated liquid, X2, therefore X2 equal to 0. So this time we have specific volume equals to Vf because it is saturated liquid. Okay, so this is straight away the value. U2 equals to Uf. This is straight away the values. So this is the time when you need to insert the suitable values into the equation. Therefore, the work done during this process is work. Okay, work done, work out equals to PdV equals to P V2 minus V1. Okay, but since our equation is a specific volume here, therefore you need to multiply with mass in here. Okay, how? Okay, be careful with this okay, but your value is actually it's already done. Okay, it's actually over the mass already. Okay, so PdV. Okay, so V equals to mV. Actually, you already have the value at here. So just multiply, put the values, okay, and put the conversion here because it is in unit of kilopascal at here. Just put the conversion, so you get this work, okay, values. Therefore, Q out. Okay, if you're wondering why we put work out at here, because just now we put it work in at here. Okay, work in into here. So we assume that we don't know whether it is a workout or work in. So we put the workout first. Okay, because the original equation is actually the work net out, right? Remember, work net out. Okay, so when you put all the values and in here, and what you get is negative, because you're not sure. Maybe you're not sure it is compression or it is a expansion. And finally, workout is actually equals to negative at here. Okay, so when you workout is equal to negative, so actually your work, okay, workout in negative. Okay, but you know that therefore it is a work in positive. Okay, in positive, work in equals to 196 kilojoule per kilogram. Okay, so how about your Q out? Okay, let's get back to this equation. Okay, so when your Q out equals to work in minus the delta U equations, right? Okay, since you have the value of U2 and U1 in over kilogram already, so everything is in specific internal energy. So we also use specific work over the mass already. Okay, this is over the mass. So Q out is also over the mass. So we use all the small letter equations. So we have this. Okay, U2 minus U1 is actually equals to UFG, right? Why? Because U2 is UF and U1 is UG. Okay, so UFG is UG minus UFG, UG minus UF, right? It's just the same. Okay, it's just the same. Okay, so you can calculate the differences of this. So you will get the UFG. So you can get this. This is the value of your Q out. So you have solved this problem. Calculate the heat transfer. Okay, heat transfer. This is the value of heat transfer. Heat transfer. So during this process, you're not sure it is Q out or Q in. Okay, so the heat being transferred. Okay, it is positive value, and the work done during this process, you're not sure it is work in or work out. So based on your value, it is negative or positive. Okay, so you have settled here. Problem solved.